drum. But as soon as as soon as if suppose this machine has been started vibrating, this has been started vibrating, what is going to happen? This will also move, and based upon this there will be a motion either in this particular direction. I will draw it in the other manner. Okay, either in that particular manner, or it can move in this manner also, or even it can move in this particular manner also. So your light radiation will fall over here, and there is a continuous vibration. It will try to come and try to vibrate depending upon the vibration. Depending upon the vibration means that light which is going to be reflected, its amplitude, its amplitude is upon totally based upon the vibration of a vibrating body. Vibration of vibrating body. If body is vibrating with a higher amplitude, or body is vibrating, vibration is more, at that time your amplitude is also more. And if your vibration is less or decrease, at that time your amplitude will also decrease. Okay, so based on this you people are getting the trace, and you can calibrate that trace, or you can come to conclusion what is the condition of vibration of that one. So that one has been specified. So light source sends a light signal through a lens on a mirror. The mirror is attached to a vibrating body by mean of some linkage. So light is reflected from the mirror. So here this one is a mirror actually. So this mirror is trying to generate a output. This mirror will also vibrate. That mirror falls on a sensitized film on a revolving drum and plots a displacement of a vibration. So as I have told, it can either move to this direction, either move to this direction, either move to this direction. It can be a straight, it can be in opposite direction. Likewise, it can have any movement depending upon the vibration. So amplitude you people are getting across that one. So this is the basic concept. Simple potentiometer. Now, simple potentiometer. In simple potentiometer, what is there? If suppose I am having a resistance which has been excited by some source. This is the excitation by some source. And here I am measuring the resultant output. So I will represent that particular part. Okay. So this one I will represent with, okay, with the other color. So over here I am having this pointer. Now what is happening? Here I am measuring the output voltage. Okay. So here I am providing the excitation. I am getting the voltage. As I move on this one back and forth. The similar concept is incorporated over here. Now how this is incorporated in this particular field? So simple aspect that over here we are having a resistance, then we people are having a vibrating body over here, and to this vibrating body this needle is connected. This is the excitation part, and based upon this one here across the resistance, if you try to reduce the resistance, your voltage will increase. Your voltage will increase. If you try to move this pointer to this side, this resistance is more, so your voltage will decrease. Your voltage will decrease as per the Ohm's law, because in the path your resistance is more. So likewise, the vibrating body will either try to move in the upward direction. This one will try to move in the upward direction or downward direction, based on which you are going to get the voltage. Based on which you people are going to get the voltage, and this voltage is calibrated in terms of vibrations. Okay, so if vibration is more, movement will be more, and voltage variation will also be more. If vibration less, at that time movement will less, and you people will get in proportion voltage. If vibration null, this will stand at particular position, and the resultant output will be zero across the voltmeter, or whatever output which is expected, that will be same. Okay. So it consists of a voltmeter, a battery, and a resistance. A needle is connected to a vibrating body and it is allowed to slide on the resistance. The change in voltage due to movement of the needle on the resistance is recorded. This voltage is proportional to the amplitude or the voltage. Then capacitive type. So capacitive type, it is also a simple one. This particular one is the vibrating body, and here is the probe. And as per our definition, if your area has been changed, this one is the fixed, this one is the fixed. Only this plate is vibrating one. This plate is vibrating one, and this is connected to vibrating body. When and as per as the capacitance, it is capacitance is the function of d, that is distance. As its distance changes, epsilon is permittivity and area. Though it is not changing the area, but it is changing the distance. It is changing the distance. Okay. So easily you people can measure the this one. You people can measure the resultant output. Okay. Using capacitive, because your capacitance is going to change. Your capacitance is going to change. So over here, air gap has been taken under consideration. Air gap has been taken under consideration, and the output voltage which is generated, that is totally depend upon the vibrating body, because that vibrating body is going to create a air gap, and that air gap is nothing but the distance which is calibrated in terms of vibrations or in electrical signal, and that electrical output voltage is calibrated in terms of vibratory motion. Okay. Mutual inductance. Mutual inductance is similar to that of your LVDT. So here also, similar to that of your this one capacitive type. Here also your air gap gets vary, and flux linkage, that is phi, will increase or decrease depending upon the air gap which is present over here. So vibrations are more, air gap will increase. Vibration less, air gap will reduce. Okay. So likewise, you people are the eddy current that has been generated, that can be used to generate the output voltage. Okay. So very simple concept. So the mutual inductance pickup is also a non-conducting active pickup, very useful for a non-magnetic metallic vibratory surface. So mutual inductance helium changes due to the vibration in the air gap between vibrating surface and pickup. This change field due to a eddy current in a vibrating body. Field opposes the field set up by primary coil. Output voltage is modulated by vibratory motion, and demodulated output is proportional to the displacement. So this is non-contact type. Previous one is non-contact type, and another which we have studied, all are contact type of sensors, with help of which we people can measure the